Hi, Trig. We are starting our new chapter, chapter 3, and as you see by the title, it's called Radian Measure. Some of you have had pre-calculus, or even in Honors Algebra 2, I think we go into the radian a little bit, a different way to measure an angle, okay? We have a football field. We know it's 100 yards, right? 100 yards for a football field. What if we wanted to measure it in meters? Same length of the football field. I still have to run that far, but how many meters is that? Here we have this nice little converter. You put the yards, it converts how many meters? So 91.44 meters. Okay, if I wanted to know how many meters 50 yards was, it's 45.72. Okay, there's lots of things in life where sometimes we want it measured in one way, sometimes we want it measured in another way. Similar, all radian measures are another way to measure an angle, okay? So we've been doing degrees in chapters 1 and 2. We've been talking about degrees. We know that a degree or a completely around the whole circle is 360 degrees. Halfway around is 180 degrees. We're familiar with that, I think. What we're going to be talking about now, instead of theta being in degrees, we sometimes are going to measure it in radians, which simply is how far. It's a more like a distance. It's a mathematical number. Okay, not a degree, but like a number. Like how far did I open this angle? Okay, we let S denote arc length. Okay, how far? That's this length. Theta is still the central angle. R is the radius of the circle that we happen to be using. Okay, so this radian measure, a radian is the angle's arc length divided by the radius. Okay, it's a ratio of the arc length divided by the radius. Let me just try to help you visualize this a little bit. We'll come back to that, okay? Most of us learned that the circumference of a circle is 2 pi r, right? That's the distance around the circle. You take 2 times pi times the radius. Okay, that's the circumference. That's how far this is. How many degrees did I go if I went the whole way around the circle? The degrees, I don't have my pencil with me. 360, right? No matter what the radius is, I went 360 degrees, right? Okay, I want you to relate the 2 pi and the 360 degrees as we go through here, okay? What if we wanted half the distance around the circle, okay? I just want to know half of that. So what I would do is take half 2 pi r. Isn't that what we would do? I would take half of 2 pi r. Does that make sense? Well, half of 2, I think, is 1. So another way to write this would just be pi times the radius. That would be halfway around. Okay, halfway around is just pi r. How many degrees did I go if I went halfway? Halfway is what, 180 degrees? Okay, think about 180 degrees, and here we have pi. I'm ignoring the radius for a second, okay, because the degrees ignores the radius. So, I'm just thinking the whole way around was 2 pi times the radius. The degrees were 360. Halfway around was half of 2 pi r. That's this distance. If I want to know what that length of that red marker is, it's half of the whole thing, so half of 2 pi r, or pi times the radius. And then I went through 180 degrees. What if I wanted to do a quarter of the way? Just a quarter. What if we wanted a quarter of the distance? Well, then I'd take 1/4 of 2 pi r, right? The whole way is 2 pi r. So I take a fourth of 2 pi r. Well, a fourth of 2 is 2/4 or a half, right? So I'd have a half pi r. And instead of writing a half pi, we usually write pi over 2, okay? How many degrees did I go there? 90, right? 90 degrees. So 90 degrees goes with a quarter of the way around the circle, or a quarter of 2 pi r, which is pi over 2 times r. Okay, those of you, hopefully you're getting the idea maybe a little bit. I hope so. All right, so what about the blue part? How far is the blue part then? Let's think about it. I already, we did the quarter of the way. That's 1/4 of 2 pi r. That looks like about half of that, right? So would you say 1/8 of 2 pi r? Well, that, if I want to know how far, the length of this blue thing, okay, it's half of this quarter. So it's 1/8 of 2 pi r. That would be, what's 2/8? 1/4? So pi over 4 times the radius. The degrees I went was 45 degrees. Okay? Right? So if I ignore the radius, this pi over 4 ends up being my radian measure. 45 degrees is the degree measure. They're the same. One's in radians, one is in degrees. The yellow, how far is the yellow part? Goodness sakes. I went 3/4 of the way around, right? 3/4 of the way around. So 3/4 times the 2 pi r. 3/4 of 2 pi r, that would be 3 times 2 is 6. 6/4 is 3/2. The way we usually write that is 3 pi over 2. It's 3/2 pi. It's 1.5 pi. Okay, the degrees I went there were 270 degrees. 270 degrees relates to the 3 pi over 2 in radians. Okay, I'm going to show you the way to get from radians to degrees and degrees to radians. Just like the football field, there's a little formula to get from yards to meters and meters to yards. Okay, so there's this way, but I want you to understand what you're finding. I think that helps if you start just cutting the circle in chunks, okay? Half of 360 is 180, okay? Half of 2 pi is pi. So when I'm halfway around, I'm at pi. So again, this is what I want you to, maybe now this makes a little more sense. This radian measure, we're going to take the arc length divided by however long the radius is. That's our theta. If you do want the arc length, you can take the radius times theta as long as theta is measured in angles. Or theta, the angle theta is measured in radians. Okay? Here's the little formula. If you want to get from degrees to radians, okay, then you're going to multiply by pi over 180. We could have said 2 pi over 360, okay, because 2 pi is the whole way around the circle, right? 2 pi r. 2 pi is the whole way around the circle. 360 degrees is the whole way around the circle. But if you divide, let's make it easier. It's pi over 180. Half of 360 is 180. So anyway, to multiply a degree measure by pi over 180, that'll convert it to radians. Flip it if you have a radian measure and you want to convert it to degrees. Pi over 180, 180 over pi. Okay, so try these. Let's convert each degree measure to radians. 45 degrees. We already did it. 45 degrees. I told you 45 degrees is 1/8 of the way around the circle, isn't it? 45 times 8 is 360. Okay, I'm 1/8 of the way around the circle, 45 degrees. 1/8 of 2 pi r is pi over 4 r. Okay, so, but We'll do it the old way. We'll do it this new way. I mean, 45 times pi over 180. Let's see, 45 goes into 180 actually 4 times. That ends up being pi over 4. I knew that. It's pi over 4 radian. 45 degrees, pi over 4 radian. Just like 100 yards was whatever it was in meters, okay? It's just degrees, radius. The same exact angle opening. It's just, I can call it 45 degrees if I want. I can call it pi over 4 radian. Depends what I want to be in. Negative 270 degrees. I take negative 270 times pi over 180. Of course, the zeros cancel. 27 over 18. 9 goes into each of those. 3 pi over 2. And we had seen that. We were 3/4 of the way around, right? 3/4 times 2 pi. Anyway. And the negative just stays. If it's a negative degree, it's going to be a negative radian. Okay. Oh, I'm sorry. I guess I didn't do the 249.8 degrees. If you can't get it into a nice fraction, you know, you can just estimate it. Notice this is a squiggly. It's almost equal to. Okay. Nothing canceled out here. I couldn't get it into a nice fraction. So I just took 249.8 times pi and divided that by 180. Notice there's not a pi here anymore. I multiplied the pi in. So it's about 4.3, 4.360, okay, to the nearest thousandths. All right, let's go the other way. Let's say I have 9 pi over 4. Now I have to think. This is already in radian. I'm going to change it to degrees, so I'm going to multiply by 180 over pi. Ooh, isn't that nice? The pi's disappear. You get 405 degrees. Try the negative 5 pi over 6. You can, of course, pause me, you know, and so that you can do it and then see if you get the right answer. Multiplying by 180 over pi, the pi's disappear again. Yay. 6 goes into 180 30 times. 30 times 5, yep. Negative 150 degrees is the same as negative 5 pi over 6. Now, where's the pi here? Well, it was absorbed. Okay, there's not always a pi in radian measure. This is 4.25 radians. Okay, think about it, guys. Was pi 3.14? When I'm pi radians, we already said that's the same as 180 degrees. Okay, pi radians, that's 3.14. So twice that would be 6.28-ish. Okay, so I'm at 4 radians. I'm somewhere after 3. Let's see where we are. About 243 degrees. Okay, I took it times 180 over pi. Notice the squiggly again. It's about 243.5 degrees. So that makes sense to me. We thought we're bigger than 3.14, but we're not to 6. Okay, 243.5 degrees. All right. So let's be very careful when we think about the difference between a degree and a radian. It's huge. Here's 30 degrees. Here's 30 radians. We have to go, what, 6? We said it's about 6 times around 6 radians, 6.28. So 6, 12, and, you know, I have to go this many times around to get to 30 radians. Okay? The difference between an angle of 30 degrees and an angle of 30 radians. Right, so be careful. All right. Unit circle. What we have here, guys, is we want to memorize some of these common angles like we had with the degrees and the sine and the cosine. What we're doing with the word unit, we are going to let the radius of this circle be 1. I don't know, 1 what? 1 foot, 1 inch, 1 meter, 1 yard, 1 something, okay? It's 1 whatever, all right? And then we're going to come back and we're going to start filling this in because I noticed that we're already at 1446. Okay, so get your unit circle ready and come back for part 2. Ready?